Many people experience a mental block the moment numbers are replaced by letters in a math problem. This specific freeze-up is a common reaction to a perceived increase in complexity. Algebra is a system for organizing information. You take verbal descriptions and place them into a grid, using symbols to track values. We will use the framework found in Sham's outline of elementary algebra to guide this translation. This text provides a structured approach to breaking down equations into manageable parts. In 5 minutes, you will take a verbal word problem, translate it into an equation, solve it, and use a mathematical proof to confirm your answer is correct. To follow along, you need a pencil, a piece of paper, and an optional basic calculator. Replacing English words with algebraic symbols provides a consistent method to process logic behind real-world problems. The letters used in algebra are simply placeholders. Each letter represents a blank space, a value that is currently unknown but can be discovered. In arithmetic, you likely solved problems using a blank line for the missing answer. In algebra, we replace that line with the letter X. Go ahead and write an X on your paper. We are going to translate a specific sentence into math. The sentence is, a number plus 5 equals 12. We translate this phrase by phrase. The first part, a number, represents our unknown value, so it becomes our blue X. Plus 5 becomes the mathematical symbols plus 5, and equals 12 becomes the equal sign and the number 12. This direct translation has converted a verbal concept into a mathematical framework that is ready to be solved. To solve this, we must look at the equal sign as more than a signal for an answer. It represents a physical pivot point where both sides must remain equal. A pan-balance scale is the best way to visualize this. For the equation to stay valid, the weight on the left must always match the weight on the right. We place our expression, x plus 5, on the left pan and the number 12 on the right. The scale sits in perfect equilibrium. This is governed by the rule of equality. It requires that any mathematical operation performed on the left side must be performed identically on the right side. If you apply an operation to only one side of the equation, the scale tips. The balance is lost and the mathematical statement is no longer true. Maintaining this bilateral balance is the primary requirement for solving any algebraic equation. Our goal is to isolate the variable x. We want the x to be the only thing remaining on the left side of the equal sign. Currently, the plus 5 is attached to the x, preventing us from seeing the variable's value. We remove this obstacle by using an inverse operation. An inverse is the exact opposite action. Since the equation currently adds 5, we will use subtraction to undo it. Write a minus 5 directly under the plus 5. A positive 5 and a negative 5 result in 0, leaving the x by itself on the next line. To follow the rule of equality, you must also write minus 5 under the 12th. 12 minus 5 is 7. The equation now tells us that x equals 7. Solving an equation is a systematic process of using inverse actions to determine the numerical value of the unknown. A distinct advantage of algebra is the ability to prove your result. You can confirm your answer is correct before moving on to the next problem. We use substitution to do this. Return to the original translated equation, x plus 5 equals 12. Replace the x with your answer, 7. 7 plus 5 is 12, which matches the right side of the equation perfectly. When the two sides match, the balance is verified. You have used logic to mathematically prove that your answer is correct. You have now successfully translated a verbal concept, isolated a variable through inverse operations, and verified the result. This framework, found in Chapter 2 of the Sham's text, scales to more complex problems. If a problem uses multiplication, you would use division as the inverse. The rule of equality remains the same. Practice these steps now on a fresh piece of paper. Try to solve this sentence. A number minus 3 equals 10. Mastering this translation and balancing act provides the foundational language necessary